Everyone, let me just say thanks for attending the long coffee break. We're going to do a semi-weekly moving forward with different topics on the coffee break. So thanks for attending. Just for everybody who's in, this is recorded. We're going to post this to YouTube afterwards, so you can always send it to others, refer back to it. Or whatnot. So just be aware of that. And moving forward, we will be able to have a question and answer session after this conversation. So the only thing I'd ask that if you do have a question, please just type it into the chat. I'll be monitoring the chat. And then when we're towards the end, I'll ask a bunch of those questions to Matt. After we're past the 10:15, 10:20 mark, we'll probably close the presentation, but you're welcome to stay on if you have any particular questions about what we discussed, any projects that you're working on that you want to discuss in a more intimate fashion, and we can allow as much time as you'd like for that. But joining us today, we have Matt Thielkin. He is with Thermacor, and he's been there for about 11 years and has a lot of in-depth information, a lot of previous projects that have been done, both large and small. We have quite a bit of Thermacor that's been installed throughout Utah. So you may have worked on these projects before, but hopefully Matt will bring a little bit more information to consider when you are applying these type of underground piping installations and other things for your specifications and options that your clients might like to exercise as well. So Matt, if you'd like to go ahead, you have the reins. I think you can take control.
Very good. Yeah. So just to point out, I will not be tracking the chat bar, you're talking about, because I'm incapable of doing more than one thing at once. So I do appreciate everybody, your attendance here today. Thanks, Jeff, for having me on. Again, as Jeff mentioned, my name is Matt Thielkin with Thermacor Process. I'm going to speak to you a little bit about a few ways that we can help protect your underground piping distribution networks. So when it comes to the district heating and cooling markets, really our piping technology isn't what you'd say is on the cutting edge of the spectrum when it comes to all the advances we've seen in the various pumps, chillers, boilers, heat exchangers, et cetera. So most of our systems are buried and forgotten, which is exactly the reason why that can lead to problems if they're not installed right. So I put together a short presentation today with a few items that can be included in your projects that can hopefully eliminate some of the problems that we see are encountered most often. So let's see here. So that said, we'll provide a brief product description, specifically discussing our two main staples for both high temperature and low temperature distribution. We're going to touch on the failure mode of pre-insulated piping systems, and then address a few items that can go a long way to solving these problems, which includes our electrofusion pressure testable joint closures, the ERM leak detection system, and then our direct buried pre-insulated valves. Now, for those of you who are unfamiliar with Thermacor, we are one of the largest manufacturers of pre-insulated piping systems here domestically in the U.S., and we've been providing these quality insulated systems since 1964 and are continually investing in our technology to make our systems more efficient and more economical. So moving into these the product lines here, the first main product line here is our Ferrotherm system. This is going to be for operating temperatures under 250 F. So it's going to cover most of your hot water and chilled water distribution systems. As you can see in the photo here, it's comprised of a carbon steel carrier pipe, polyurethane foam insulation, and a high density polyethylene jacketing. And so this is what we call a bonded foam system, meaning that the entire system moves underground as one unit. We're going to account for expansion compensation externally with bolster padding materials at expansion loops and other changes in direction. So next we've got our next main product type, which is our Duotherm 505. This is for high temperature distribution, which is going to capture your steam and condensate and high temperature hot water applications. Again, we're starting with a carbon steel carrier pipe, but this time we're going to use a wrapped insulation, which is rated to 1200 F. Now, most commonly, this would either be a mineral wool or an aerogel insulation. And this is going to be inside a 10 gauge steel casing, insulated again with polyurethane foam and a high density polyethylene jacketing. So this is what we call our Class A system. It is drainable, dryable, and testable. And the carrier pipe is centered and supported within the conduit which allows the pipe to move internally and independent of that outer casing and outer jacketing. So the common theme between each of these low temperature and high temperature systems is the application of the polyurethane foam and the HDPE jacketing. So we utilize a spray applied polyurethane foam, which allows us to apply that HDPE jacketing directly to the foam after we visually inspect it. So that's going to guarantee that there's no voids in our system. So both the foam and the jacketing are high dielectric strength materials. And so that means we're eliminating the need for any additional corrosion coatings. And of course, there's no cathodic protection of any kind needed on the system. Now, along with 95% of all the other pre-insulated piping manufacturers globally, we've elected to standardize on our HDPE as our primary jacketing material. So the jacket is homogeneous, which means that any breaches in the jacket are readily visible and easily repaired prior to burial. It has an elongation value of 400 to 800%, which means that material is going to flex rather than break under most sharp impact loads. And finally, of equal importance is that it's a thermoplastic jacketing material, which makes it fusible. So there's really no other jacketing material in our market that can thermally fuse to itself. And this characteristic allows us to manufacture a field weld repair kit that can be fused and pressure tested. And this is going to lead me into the main failure mode of pre-insulated piping systems. And the chart you can see here is from information gathered in Germany. As you'll see, the data is dated, but the theme remains consistent. The number one failure mode of these pre-insulated distribution systems is from failed joint closures that are put on the weld locations in the field. Now, typically, this is going to be due to improperly installed joint closures, where water ingress from the outside in is the killer of these systems, not internal corrosion or carrier pipe leaks. So since 1997, we've been manufacturing electrofusion pressure testable joint closures. And because we don't have an ASTM standard for pre-insulated piping systems here in the US, we've had our closures tested to the European EN 489 standards. And when compared to adhesive back closures or other alternative industry standard closures, this electrofusion joint is significantly more robust. And when installed and pressure tested, the joint's going to guarantee the watertight integrity of this jacket. So you can see in this next picture, we're actually utilizing an HDPE split sleeve. It's manufactured with the same 4710 resin that we utilize in our jacket. And this material is actually the same resin that's used in HDPE pressure pipe. So the concept here is very similar to an electrofusion coupling that you'd use on an HDPE water line. Where we have a stainless steel wire that's embedded inside a 4710 resin, and that wire is extrusion welded along the circumferential and longitudinal seams of the split sleeve here at my shop. So you'll notice these leads that are coming out of the closure, and we're simply connecting this to a dedicated power source and allowing it to cook. So the material actually fuses the closure to the surrounding jacket. So once the joint cooks for about 20 minutes and then is allowed to cool, we're going to put a positive pressure test on it of about 5 pounds in the joint. If no air escapes the joint, then we can be certain that no water can penetrate that joint. So at the end of the day, we're going to provide a polyethylene friction weld plug and a special drill bit that seals this test hole. And then finally, as a belt and suspenders, we'll use a heat shrinkable sleeve over that entire configuration. So one thing also that I think it's important to note is that all of this work is being performed at the 12 o'clock position in the trench. So one of the biggest drawbacks that we see to using the shrinkable closures is that in order to properly install them, the contractor needs to get their flames under that pipe at the 6 o'clock position. And so we often see that as an area where not enough attention is given. So here in this next picture, we're demonstrating a cross section of that fusion weld. And in performing the tensile strength tests on this joint, the material actually fails on the jacket as opposed to at the weld, as that weld area becomes stronger than the material surrounding it. And so you can visually see in this picture that there's absolutely zero pathway for water ingress into the system that's sealed with this closure. And so really this is the best way that we see to guarantee a proper installation. As part of these systems, Thermacor requires a log sheet to be completed with all the pressure test information on every single joint in order to issue the warranty, so that we know that it's done correctly. But in the event that a closure is still improperly installed, or there's damage to the piping system during subsequent excavations, we can also include our electric resistance monitoring leak detection system. And that's going to be applicable to any system that uses our exterior polyurethane foam or HDPE jacketing. So we're talking about both the bonded foam systems and the Class A conduit systems as well. So this ERM system works exclusively on Ohm's law, so we know there's no false alarms. And really the ERM leak detection system minimizes costly repairs by detecting leaks before any serious damage occurs, which holds both the manufacturer and the contractor accountable for their work. So essentially it's going to tell on us if something's wrong. The ERM system is simply a bare copper wire that's embedded between the foam and the jacket. And we're measuring the resistance between that bare copper wire and that carbon steel pipe. And so if resistance is infinite, we know that the system is dry. And if resistance is approaching zero, we know that we've got moisture in the system. So it's a really simple concept. And taking it a little bit further here, in addition to knowing that we have a leak, we can also utilize the leak detection system to locate a leak in the system by utilizing a TDR or time domain reflectometer. So essentially we're sending a pulse of energy down the wire, and depending on how long it takes for that wire to, or for that pulse of energy to get back to the instrument, we can locate a leak or fault to what we term as backhoe accuracy. So all of our systems also come with a field weld map, so we can further isolate where to dig by looking for the field weld location that's going to be closest to our TDR readings. So in summary on these two components, including the fusion closures will keep water out of the system, and including the leak detection system is going to allow you to proactively monitor the piping system. And finally, for discussion today, we'll look at these long stem valves that are designed to be pre-insulated for direct burial. These are for bonded foam systems only, so they're going to be applicable to your hot water and chill water systems, unfortunately not currently rated for steam. And the idea here is that we're eliminating yet one more problem that faces you all as designers of district heating and cooling systems. And that problem is, how do we keep our valve vaults from flooding and increase the longevity of the mechanical equipment inside the vault? So the answer, in our opinion, is to use these fully welded and insulated valves and eliminate your vaults altogether. So these valves are low profile, which means they can be insulated and easily integrated into the system. And we actually insulate and jacket the valve all the way up to the stainless steel operating nut so that we're fully protecting all the components within the valve. So over the past decade or so, we've developed a relationship with Vexvi out of Finland. If you're unfamiliar with Vexvi, they're one of the foremost valve manufacturers for district heating and cooling valves in the European market. And all these valves are going to have a stainless steel ball or disc, and they're going to be weld end, whether we're providing ball valves or butterfly valves. So we're not having to worry about flange connections underground. The ball valves are available up to 24-inch in diameter, and butterfly valves are used for anything larger than 24-inch. And each of the valves are designed to operate from grade with a T-key. You can see here in this graph that the cost curve of the butterfly valve versus the ball valve starts to diverge around the 12-inch or 300 millimeter mark. But again, most of our customers are going to prefer the ball valve whenever possible. Most of the applications that we're using, we're providing reduced port ball valves. This keeps the profile smaller and easier to insulate and easier to handle in the field. And with that reduced bore valve, it's important to note that there is a small pressure loss, but generally that's acceptable for most of the projects we service. And of course, there are full bore valves available, but again, that is going to require more material, and so that's going to increase both the price and the lead time of the valve. So on the next slide here, you can see the floating construction of the ball, which guarantees the tightness of the valve when pressure difference is high. And then, of course, the spring plate on the right-hand side guarantees the tightness of the valve when the pressure difference is low. Now, again, the majority of our hydronic piping systems are going to be under 24-inch, which means most of our customers prefer the ball valves whenever possible. But we do offer the butterfly valves. These valves are specially designed for heating and cooling. They're metal seated and maintenance free. And again, they're going to offer total tightness in both flow directions with that metal to metal sealing system. The body is going to be manufactured from a fully welded carbon steel pipe. Now, whether it's a ball valve or a butterfly valve, we design them into the systems at or around anchor locations so that we eliminate any bending or shearing forces on that valve shaft. And because we're able to insulate and jacket these valves in our shop, we're able to guarantee that they're watertight. So this is going to eliminate the typical maintenance costs as well as added cost of potentially premature replacement. So finally, in recapping, the three easiest ways that we see to increase the longevity of your investment are to make sure with the fusion closures that the system is properly sealed and tested. Be proactive so that if you do have a leak in the system, we know when and we know where. And take advantage of what we consider the low-hanging fruit by eliminating your vaults wherever possible, as those are some of the areas that we know to be problematic. So again, we certainly appreciate the time you shared with us today, and whether you guys are currently utilizing any of these components or would like to incorporate them into the designs. Of course, Long Building Technologies and Thermacor are happy to provide any additional information or design assistance. So again, these are just a few ways that are inexpensive to help you protect those underground piping investments. So please just let us know how we can help.
Well, thanks, Matt. And that's a great overview of what we can provide through Thermacor. And I'd tell everyone, and Matt, if you could mute your, I think I'm getting some feedback, but if I could say to everybody, certainly if you do have an application, we can go into further details on any of these items, and we can also be of a design assistance. At this point, if you have questions, please do type them into chat. And I will start, Matt, by asking some of the questions that I often receive. What is some of the standard general rules for expansion compensation? How often can we say generally that we need things like expansion compensators within an underground system?
Yeah, so the general rules are that we're going to anchor the system anywhere we've got a penetration into a building or vault. And of course, we're going to use those anchors to push the movement towards, natural changes in direction or into expansion loops that we physically put into the system. And that the frequency of those loops or natural bends is going to be determined by the temperature, of course. So how many inches can we push into an elbow? So I guess the short answer to that is that the bonded foam systems, each elbow we try to minimize. Or we try to use a maximum amount of movement of about 3 inches into each elbow. So an expansion loop could take up 6 inches of movement with movement coming from either side. And on the conduit style systems where that pipe is free to move internally independent of the conduit, we can generally put 5 to 6 inches in each elbow. So we're taking 10 to 12 inches of expansion into one loop. So we really try to minimize having to put those in as much as possible, because of course, the more field welds that you have, the more issues you could potentially have, as we've discussed today.
And the ERM leak detection system is a great investment. There's a lot of value in that for the owner, given if there is a problem down the line. But how does that tie in? Is there a BAS interface that's going to alarm? Is there an audible bell? Is it something that needs to be tested every so often?
Yeah, so we have a couple different ways to monitor it. Number one, it can be a point of use alarm panel, which we provide with all the systems. So in your mechanical room, it would go into alarm, it would flashing lights, etc. It also comes with dry contact, so you can connect it to any BMS system. And then it also has the option. We don't use it a ton because most people are connecting to their BMS system, but we can also put in a mobile or wireless card so that you get alerts via text, email, etc. As a standalone, as opposed to being connected into the BMS.
The last question I would have is, what it seems that a lot of the fault in these systems is in the installation itself, and it's a very critical part. You mentioned a few of the things that is done in order to maintain warranty and the steps that the the installer might take. But is there any other advice that you'd offer in specifying engineer that he could help ensure that this is installed as properly as possible for a lifetime worth of benefit?
Yeah, so I do think that it's important to have some sort of owner buy-in on the installation of these systems. We can put all the checks and balances in place that that are available to us, including the logs that we talked about. So when we've got an ERM system included, we're going to come out and we're going to show them how to hook up the wire. So you're testing for isolation, resistance, continuity, et cetera, on the copper wire. So we're going to show them how to do that. And then, of course, we can't be on site 100% of the time, but we will come back out at the end of the installation and we're going to map the system. So we're going to, again, check it for isolation, continuity, resistance, make sure that there's no faults in the system. We're going to go over their pressure testable electrofusion log, make sure that those pressure tests are present on each joint. And so really, at the end of the day, that's about the max that we can do to make sure that these are done right. If you have an owner's rep or somebody on site who can be present during these joints happening so that they also witness the pressure test, that's huge. So getting the owner buy-in, since they generally already have somebody there on location, the joints, you can probably do one every couple hours, I guess, for two guys. So if they've got multiple crews, it's not a lot of time they'd have to spend on site. So that would be a recommendation I would make, is to get some sort of owner buy-in into the installation process.
And of course, in this day and age, that might be able to be part of the commissioning agent's bill of materials, is to oversee some of those too, to make sure that it's done properly.
That's the thought. The campuses that we work with that have that sort of active role in the installation, the problems are minimized in fractions of what you'd see otherwise.
Very good. Well, I'd like to remind everyone we're going to try and do this weekly. We've got about 3 or 4 weeks of a presentation set up for you now, and we'll be rolling out more. The next one is managing HVAC sound expectations and risk, which we will have guests from Fibroacoustics attending that one. So hopefully you can make it. We will publish this recording after we're finished here. And at this point, if you want to take yourself off mute and ask further questions or type them in, we'll certainly be able to entertain them now. But I'd like to thank everyone for their attendance and hope to see you next week.